My dear students, other viewers and listeners, I, Professor Manohar Lal, Director, School of Computer and Information Sciences, welcome you to this lecture on fuzzy logic, why and what. Friends, computers are very well known for crunching numbers, applying various arithmetical operations like addition, multiplication, division, etc. We have also seen in our previous lectures that computers are also used for reasoning, especially for deductive reasoning. A deductive reasoning is one in which whenever the given assumptions are either true or false but their truth values are given, then whatever is the consequence of that is deterministic. However, in our everyday life, we find a lot of situations, as I will explain later, in which it is not possible for us to have precise functional determinism of the operations which we applied in order to solve everyday problems. So for this purpose, one of the ways of handling this type of reasoning is through fuzzy logic. I will explain during the lecture what is fuzzy logic, what are its salient features, why it is studied, and what are its applications, etc. But to begin with, let us have a look at the possible topics which may be covered during these two lectures. Please have a look at the slide. The topics which we may be discussing today are intrinsic concept of fuzziness. I will give a number of examples by which we will be able to explain what is meant by fuzziness, by which we will be able to understand or at least to have a rough idea about the concept of fuzzy. Then we will explain further examples of fuzzy through fuzzy rules. Then further we explain why ultimately fuzziness is required. After that we will have a number of examples of operations on fuzzy sets. And then we will see that a number of operations which are not there on the normal sets are also there on fuzzy sets. Then we will explain the concept of fuzzy relation, fuzzy logic, etc. And finally, we will give a number of references for future consultations, etc. So with this, friends, I will explain first of all through a number of examples that what is fuzziness at last. Why our conventional methods of reasoning through arithmetic operations or whatever are the operations available in symbolic logic, particularly propositional logic and predicate logic, are not sufficient to handle the situations which involve this type of variables. Please look at the slide. When we say healthy person, can we say that there are definite deterministic values by which a person can be said to be healthy? If the health of a person is determined in terms of a number of parameters, for example, the temperature, the blood pressure, the sugar level, etc. But can we say that a person is healthy only when the temperature of the body is 98.4 degrees Fahrenheit? No, it is not. Even a person may be healthy at 98 degree or even lower, and may be healthy even at 99 degree, etc. So there is not an exact degree, an exact mathematical number by which, if it is the temperature of a person, we can say that the person is healthy. No. Similarly, in the case of blood pressure, the variation is still much more as compared to the temperature. That is, a person may have different blood pressures and still may be called healthy. Similar is the situation about other parameters like sugar level, etc., etc. So friends, when we say a person is healthy, it doesn't mean some definite values of the various parameters which are used to determine the health of a person. Similarly, when we say patient is depressed, now patient may be depressed because of various reasons, and the degree of depression may be again variable. So depression is not something which can be deterministic. We take the everyday example of old and young. Now we can't say person is old at this particular age. As soon as we are born, the process of becoming old starts, and it starts and goes on very gradually, day by day, but no one particular day we fix that when a person is 25 years and then the next day he'll be old, nothing like that. So these are words. Similarly, milk is sweet. You take a glass of milk, put one sugar small cube and dissolve it. Then test the sweetness. Again you add few more small cubes. You again test after dissolving those. Now the sweetness has increased. But earlier also the milk was sweet. Now also the milk is sweet, and if you add a number of, say 2 or 3 more spoons, it may become sweeter and sweeter, but it is sweet. So we cannot say when the milk has become sweet. It depends, it is the variation of the degree of sweetness, of course, about which we can talk, but exactly or precisely we can't say when the milk has become sweet. Similarly, when we have beautiful painting. So everyday life concepts which are forming a part of our everyday language have a number of adjectives particularly which cannot be determined in the mathematical sense. However, these are used in everyday language, and these are used in the expression of the problems also. These are also used in the expression of the solutions also. How to capture these notions so that the power of reasoning used by human beings in solving problems involving such indeterministic variables can also be embedded in the computer system is the problem under consideration. And in this respect, the fuzzy logic is a very powerful tool which helps us in conveying our reasoning capabilities to the computer systems so that the computers are also able to solve the problems involving this type of variables like healthy, old, depressed, etc. So friends, I hope you understand why fuzzy logic is studied. The basic reason is that human beings are still much better than the computer systems in solving everyday life problems in which particularly the variables involved are not deterministic, and we want to embed that capability in the computer systems so that the computer systems also may help us in solving problems involving fuzzy variables or fuzzy indeterministic variables. So I take another example. Please look at the slide. That how the language can vary. For example, you take the phrase for a long period. Now this phrase for a long period may stand for a number of connotations. It may stand for 10 minutes, it may stand for even thousands of years. You can see the imprecision involved in the phrase for a long period through the 3 examples which are given on the slide. First of all, we consider dinosaurs ruled the earth for a long period. Here this for a long period stands for millions of years. But if we say it has not rained for a long period, this doesn't mean that it has not rained for millions of years. Here we may say that it has not rained for 6 months or so, or maybe even a year or 2 years. But whenever we say that it has not rained for a long period, we never mean it has not rained for millions of years. Here the period may be 6 months, 1 year, 2 years. So the same phrase for a long period here stands for just 1 or 2 years, where in the case of dinosaurs it stood for millions of years. And you take the next example. I had to wait in the doctor's room for a long period. And here we don't mean at all to say that I had to wait in the doctor's room for 1 year or 2 year or 3 years. No. It may be say about 1 hour, it may be 2 hours, it may be 3 hours. So friends, you can see that in our everyday language, we use variables, we use phrases like for a long period, which may stand for 1 hour, 2 hours, may simultaneously at the same time in some other context may stand for say 6 months or 1 year. In another context, the same phrase for a long period may stand for millions of years. So how much is the variation in the period represented by for a long period, you can see. And similarly is the situation about other phrases, other words of natural language. That is, the natural language, most of the words have imprecise meaning, they don't have definite meaning. But friends, it should not be taken as a negative thing. It is rather a strength. By using one word, we can express a number of ideas. So it is the strength of the natural language. However, when we want to convey the same to the computer systems, it becomes a negative thing in the sense that the computers are mainly designed for precise work. And we have to contrive, we have to find out ways when we have to deal with imprecision. As I'll show you a number of cases where the computer systems are not as good as the human beings are there in handling information which is not precise. But I hope the idea is very much conveyed that a number of words, number of phrases, number of sentences in our everyday language may stand for different meanings in different contexts. Now first, the rule of driving. Please look at the slides. If an obstacle is closed, I am talking of the rules of driving. If an obstacle is closed, then apply brakes immediately. Now what do you observe in this sentence? Close. Now close is a word which can be, in one context the close may be say 50 meters. In other context the close may be just 1 meter. Depends upon the situation. In the case of aeroplanes, a few kilometers may be very close. But when two human beings are walking or talking, in that particular case, even 100 meters may not be close. So friends, in this particular rule, if an obstacle is closed, then apply the brakes immediately. It depends upon whether the vehicle is a mobile or it is a motor car or it is aeroplane. Depending upon that, we have to interpret the word close. Similarly, if it is hot and humid, then it is better to keep inside the house. Now we can't say what is meant by hot. For some people even 30 degree becomes hot. I know in the European countries, if I remember a particular instance when the temperature rose to 30 in Russia. It was talked in the sense that it is quite hot. However, in Indian context, particularly in the Delhi and all that, 30 degree may not be hot. And humid, again humid in Cherrapunji may have a different meaning than the word humid may have meaning in Jaisalmer. In Jaisalmer, even a few drops fall, then we say that, oh, it has rained, because rain is very rare instance. So what I mean to say is that the same words, humid and hot, may have different meanings to different people, and this is why the two words have imprecision. The imprecision is resolved by the context under consideration. The vegetable is not properly cooked yet. Can you say when the vegetable is exactly, can you say in exact terms that the vegetable is cooked? No. Well, there is a range in which whenever the taste is there, we can say, okay, it is cooked or not cooked. But you can't say that cooked or not cooked can be deterministically or definitely determined and like that. You take the example of crossing the road. We can't have a definite rule. For example, if we go by the deterministic rules of crossing a road, what could be the method? The method of crossing the rules according to precise rules may be something like this. That first of all, we should determine the distances of all the cars coming in our direction, their distances. Then we should know their speeds. and then we should calculate the time that will be taken by those vehicles in reaching us. But if we start doing all these things, we will never be able to cross a road, particularly in Delhi when hundreds of cars are coming in our direction at variable speeds and at variable distances. But still we are able to cross the roads very safely. What I want to convey to you through these examples is that deterministic rules we are not very good in applying. How the computers are very good in applying the deterministic rules. We are very good in handling the imprecision. Rather, we are better in handling the imprecision and understanding the imprecise information as compared to the precise information. I give this example very frequently that if we say that the cloud cover is 39.76%, hardly we will be able to make any sense. However, if we say that the cloud is partially covered or it is partially clouded, we make a sense out of it. What I want to convey is that human beings are very good in handling information which has precision. However, the computer systems are very good when the information given to them is precise. But as I mentioned earlier, we want to make use of the computer systems in solving problems involving even imprecise information so that those can be an aid to us. Now, how to convey that? That is the very purpose. One of the tools for handling imprecise, to make the computers handle imprecise information better is through the fuzzy logic. So that is the rationale why we are studying the fuzzy logic. So friends, I have just, whatever I said, I have more examples to justify that human beings are much better than the computers when the information is not precise. Please look at a few of the examples which are given on the slide. On the slide, the first example says, just by looking at the eyes only and or nose only, we may recognize a person. Just by taking or feeling a small number of grains from the cooking rice bowl, we can tell whether the rice is properly cooked or not. Just by looking at few buildings, we can identify a locality or city. If you are, for example, passing by Red Fort, you can say you are in Delhi, just by looking at one building. Crossing a very busy road, as I explained, is an example where if we start working with the precise information, we may not be ever able to cross the road. So these are some of the examples which show that human beings are very comfortable with imprecision where the computers are not like that. So now, repeatedly I am saying that in order to make computers capable of handling imprecise information, in order to solve our problems, fuzzy logic is one of the tools for making computer systems capable of solving problems involving imprecision. That is the very purpose why we are studying. So friends, now first of all we like to see how we solve the problems. Particularly, the solutions of the problems are found by giving a step-by-step solution and data. Now the data generally given is in the form of numbers or in terms of logical variables on which functional operators are applied. By functional operators I mean to say is that whenever the truth values are known, then whatever is the result, its value is deterministically there. In this particular situation, the data given is in the form of numbers or in terms of logical truth values, which are precise. And for this purpose we use the sets. The concept of set is very well known. Now the fuzzy logic is an attempt to capture imprecision by generalizing the concept of set to fuzzy set. The purpose of fuzzy sets or study of fuzzy sets is how to generalize the normal set to a set or to a concept of a set which we call fuzzy set, which can capture imprecise notions like good, bad, cold, hot, tall, etc. Because all of these words are imprecise. So how can we determine or how can we express the set of all tall people? In the earlier, the conventional set notation, either a person must be tall or a person must not be tall. But this is not the situation in everyday life. You can't say that a person is not tall at 5 feet 7 inches and all of a sudden becomes tall at 5 feet 7.2 inches. It is not the situation. So how to handle this type of things? The fuzzy sets are introduced, as we'll see through the examples, but basic thing which I tell you, how the fuzzy is introduced for the purpose of solving problems with the help of computers is by generalizing the concept of set to fuzzy set. And similarly, the operations which are applied to sets or crisp sets generally are generalized to fuzzy set operations. We'll see in the rest of the lectures how these are generalized, how the operations are applied, and how these concepts of fuzzy set is used in solving everyday problem. So friends, first of all, we may have a look at one or two sentences, one of which is a precise statement and the other is an imprecise statement. The precise statement is something of the form, if income is more than 2.5 lakhs, then tax is 10% of the taxable income. Now you can see, everything is precisely given. More than 2.5 lakhs, then the tax rate is 10% of the taxable income. On the other hand, you can have imprecise statement of the form, if the forecast about the rain being slightly less than the previous year is believed, then there is around 30% probability that economy may suffer heavily. Please look at the second statement. First of all, the forecast is believed. Then there is around 30% probability. You can see a number of words or phrases are used for which no definite meaning can be assigned. But you know, this type of statements are used in everyday context. Every day the economics make such type of statements, and these are used in making arrangements, because if there is shortfall of food grains in a particular area, in advance arrangements are made so that the food grain shortage in that particular area may be met by transporting food grains from some other areas in advance. But still the imprecise information is useful, and our purpose, again repeatedly I am saying, is somehow to embed the capability of handling imprecise information by the computer systems in solving our problems. Now how we will be doing, how the computer system will be able to solve the problems by getting the notion of by defining the notions of fuzzy etc., will be the next lecture, next part of the lecture. So friends, before I introduce the concept of fuzzy in still more clear terms, let us take the example of a tall person. As I mentioned a few minutes back, tallness is not something like that at a particular height, say 5 feet 7 inches or 5 feet 8 inches, you can say a person below this height is not tall and above this is tall. What we generally think of, let us have a look at the slide. In Indian context, please look at the slide. We say a male adult is definitely tall if the height is above 6 feet. Everybody agrees. If the height of a particular person is 6 feet, he or she is definitely tall. And if a person is male adult Indian is less than 5 feet, then we say, no, the person is not at all tall. Well, this is agreed. Eh, But if the height is 5 feet 2 inches, we may say that the person is a little bit tall. Everybody agrees to this. And if the height is 5 feet 6 inches, then we say that the person is slightly tall. And if the height is 5 feet 9 inches, we say that the person is reasonably tall. So friends, through this example, we have seen that if a person is less than 5 feet, we can say in Indian context, adult and male, that the person is definitely not tall. And if the person is above 6 feet, we can say yes, the person is definitely tall. But within 5 feet and 6 feet, we didn't say that a person is neither not tall or tall. Rather, in everyday language, we use slightly tall, definitely tall, reasonably tall, etc., etc. Now, how to convey these words like little bit tall, slightly tall, reasonably tall, definitely not tall to the computer system? This is done by assigning degrees of tallness to the people. That is, we can say if the height of a particular person is less than 5 feet, then we say the degree of tallness of the person is 0. And if a person's height is more than 6 feet, then we can say the person's tallness is 1. And in between we vary the degrees of tallness depending upon the height under consideration and our conception of the height, particularly in Indian context. So friends, what we can do? We can model this. Please look at the slide. Whatever I have explained is already on the slide. You can assign a value 1 when you are sure that the person is definitely tall, that is according to our definition, the height of the person is more than 6 feet. And we can say the degree of tallness is 0 if the height of the person is, say, less than 5 feet according to our definition. But what about the other heights? So for that, please continue looking at the slide. A person who is 5 feet 2 inches, and according to our criteria, the person is a little bit tall. This little bit can be assigned a value 0.2. And when we say that if a person is 5 feet 6 inches tall, according to our definition of tallness, the person is slightly tall, the degree of tallness may be assigned as 0.4. And when the person is 5 feet 9 inches, and according to our conception of tallness, the person is reasonably tall. And this reasonably tall may be assigned a value 0.7. So on. That is, whatever the everyday language words which are otherwise precise may be made little bit precise by assigning degrees between 0 and 1. I hope the idea must be clear. And this is how the concept of fuzziness, the imprecision in everyday language is captured by transferring the sets to fuzzy sets. That is the essence of whatever the rest of the lecture is I am going to say through. So friends, now coming back to the imprecise concept. So suppose there are 5 persons in a organization. Their names are, say, Mohan, Sohan, Johan, Abdul, Abraham. I'll use this example in further elaborations, though whatever I have already said is summarized over here, but because this example is going to be used in later illustrations also, I wish you look at this example despite the fact it has already been explained. Now 5 persons, Mohan, Sohan, Johan, Abdullah and Ibrahim, have respectively heights 5 feet 2 inches, 6 feet 4 inches, 5 feet 9 inches, 4 feet 8 inches and 5 feet 6 inches respectively. So had we discussed the concept of tall in the mathematical sense, then only the second person, that is Sohan, who is 6 feet 4 inches tall, will be in the set of tall persons, and we can't say about the other persons. That is, according to the tallness in precise mathematical terms, only Sohan is a tall person, rest of the persons cannot be included. But it is injustice particularly for the person who is, say, Johan, who is 5 feet 9 inches. He is almost on the verge of becoming a tall person, but he is not included among the tall persons. And this is how, as I mentioned earlier, is the fuzzy set has come into picture. So if we use the conventional set theory, our set of tall persons consists of Singleton, Sohan, but it does not capture the everyday notion of tallness precisely. So for this purpose, what we do? As I mentioned earlier, we describe, instead of precise sets tall, the crisp set tall, we define the fuzzy set tall. And in the fuzzy set tall, instead of including names, we associate names with degrees also. And as you saw, because Mohan is 5 feet 2 inches and he is slightly tall and little bit tall and little bit has been assigned a degree point 2. So here we will include Mohan, Sohan, Johan, Abdul, even Abdul who is very short, 4 feet something. We will include it, but with a degree 0. So here, in the case of fuzzy concepts, instead of writing the names of the people only, instead of including the objects only, we write their degrees separated by a slash. So now coming back to the slide, we see that Mohan has degree of tallness 0.2, Sohan has degree of tallness as 1 because he is 6 feet 4 inches, and in the Indian context 6 feet 4 inches tall person is definitely tall. And Johan, who is 5 feet 9 inches tall, has been associated a degree of tallness as 0.7. But Abdul, who is 4 feet something and is less than 5 feet, is definitely not tall, and for definitely not we include the degree 0. So Abdul has the degree of tallness 0 and Abraham has degree 0.4. So friends, from the ordinary set tall, in which either a person inside or outside, we have generalized the concept of set to a fuzzy set, in this particular case the set of tall persons, in which we write all the members of the underlying set or the set of all names in the organization, but along with each name we are associating a degree of tallness also. I hope it is. And in the process, we have defined a new type of concept which is called fuzzy. And in this process, definitely we have done better justice to the concept of tall. The idea of tall in our minds is something like the one which is included in the second definition of tall instead of the first one, in which only Sohan is included in the set of tall persons, but rest are included because they are below 6 feet. But as I mentioned repeatedly, a person when has a height of 5 feet 11 inches is not tall, and all of a sudden becomes tall when he is or her height is say 6 feet. Because it is injustice. But because our previous mathematics is not capable to capture such things, we were forced to say that only Sohan is tall and rest of the people are not tall. So you can see, you must have started beginning seeing the importance of the concept, that it captures more and more closely our everyday concepts. So friends, now we can define similarly short. Who is a short person? Who is just opposite of tall? And again we say that set of all short people are, then only Abdul will be claiming it. But here our measure will be different. More the height, less the short. Because we have to change our outlook now. Now we are looking for short persons. A short person is a better person in our concept now. So here the degrees to be associated are to be a bit different. And for this purpose, now more the height, less the degree of shortness, and for this purpose, please look at the slide for the example. Again the same people are there. When the people are looked at or considered from the consideration of tallness, then the Mohan has degree 0.2, Sohan has degree 1, Johan has degree 0.7, Abraham has degree of tallness 0.4. But when we look at the same people from the point of view of shortness, then in that case the degrees must be reversed. because Sohan, who is 6 feet 4 inches, cannot be considered as short. So here the degree of shortness will be more when the height is less, and therefore now we can do is that in this particular case we can say Mohan, who is having very little tallness, is having higher degree of shortness, that is Mohan has degree of shortness as 0.8. Sohan, who is very, very tall and definitely tall, is not short, and therefore the degree of shortness for Sohan is 0. In the case of Johan it is 0.3, and Abdul, who is 4 feet something, is definitely short, so the degree of shortness is 1. What we have done, if you look at the degrees of tallness and degrees of shortness, what we have done is we have subtracted from 1 the degree of tallness in order to get the degree of shortness. Mohan has degree of tallness as 0.2. Therefore, Mohan's degree of shortness is 1 minus 0.2, which is 0.8. The degree of Sohan as tallness is 1. Therefore, the degree of Sohan from the point of view of shortness is 1 minus 1, which is 0. And so on and so forth. I hope you understand that it depends. The degree is to be associated with a particular person or particular object depends upon from what particular perspective we are thinking of. The same person will be having more degree as compared when the consideration is shortness, whereas earlier the same person might have very less degree. And earlier if the degree was more in the case of tallness, then in the case of shortness it becomes less. I hope it is a very common sense idea which should not be much difficult to be understood. So this is the idea of complement also. When a given set is there, we want to find out its complement in the universal set. What we do, whatever elements are present over there are excluded, and whatever were excluded earlier were included. Similar is the idea here. Inclusion means that means the degree, and if we subtract this degree from 1, then we will be getting the degree of inclusion in its opposite. I hope this is very clear to most of them. Now friends, the idea is very clear that fuzzy sets are obtained from the conventional sets by generalizing in the sense that we associate degrees with every element of the universe. The degrees range from 0 to 1. And then, how to solve problems? In the crisp sets, we apply various operations like intersection, union, complementation, etc. And by applying these operations on the sets, we get solutions of our problems when the information is precise. Now the purpose is to handle imprecise information, and particularly using fuzzy sets as tools in which degrees are associated. So the nature of fuzzy sets is similar to but not exactly same as that of the crisp sets. Then we must know what will be the intersection, what will be the union, what will be the complementation operations on fuzzy sets. Because once we know these, then we can use these in solving our problems. So in order to explain the concepts of intersection, union and complementations in fuzzy sets, first of all, we may recall the corresponding operations on sets or crisp sets, which are, we are using the term crisp set here in order to differentiate these from fuzzy sets. So please, just for a while, we just recall how the operations of intersection, union and complementations are defined on the ordinary sets. Please look at the slides. When we say two sets are equal, we know two sets are equal if and only if every element of one is in the other and every element of the other is. For example, if A and B are two sets and A is equal to 1, contains 1, 4, 3, 5, B contains 4, 1, 3, 1, 5. We know the order of elements and repetitions, etc. don't make change the set. So in that sense, the two sets A and B are equal. However, the set A and C are not equal because the set A includes the element 3 which is not in C, and the element 2 is included in C which is not in A. Therefore, in that sense, A and C are unequal sets, are not equal sets. Then we have the concept of subset. We again know that A is a subset of B if every element of A is an element of B, and vice versa. So here particularly, if we take the example of A and B and C, you can see that A is equal to 1, 2, 3, 4, 5, 6, 7, B is 4, 1, 3, 1, 5. You can see B is a subset of A. C has elements 4 and 8. And in this particular case, you can see that C is not a subset of A, because the element 8 is there in set C, which is not in A. Therefore, C is not a subset of A, but B is a subset of A, because every element of B is also an element of A. This is just to explain or just to recall what is meant by subset. Equality of set belongs to. We know in the case of set A, 1 belongs to A, 4 belongs to A, 3 belongs to A, 5 belongs to A, etc. Now, what are the corresponding definitions for fuzzy sets? As I mentioned earlier, in addition to the elements present in a particular set, in the crisp set, we have associated degrees also, and in every fuzzy set, we include every element of the universal set as an element, of course, with an associated degree of fuzziness. So, for this purpose, how the concepts of union, of intersection, of complementations are generalized in order to have or in order to define the operations of intersection, union, complementations on fuzzy sets. So friends, this is our next task. For this purpose, first of all, we define the concept of equality. For this, we take the example, let A be equal to Mohan, Sohan, Johan, Abraham with associated degrees 0.2, 1, 0.7 and 0.4. Let B be equal to Abraham with associated degree 0.4, Mohan with associated degree 0.2, Sohan with associated degree 1 and Johan with associated degrees 0.7. Now in these two cases, friends, you can very easily see that the elements in A and B, not only the elements are same, even the associated degrees are same, and from the fuzzy sets point of view, A and B are two equal sets if the same elements with same associated degrees respectively are there, then the two sets are said to be equal. However, if degree is different even for one element, then in that particular case we say that the two sets are unequal. So friends, we will continue our discussion in the next lecture of the various operations on fuzzy sets.